In this unit, we're talking about trade-offs, and in the reading, you read about indifference curves and utility and trying to maximize that utility within a certain budget constraint. And so in this technical video, I'm going to walk you through how we solve a utility maximization problem. By utility maximization, we mean that we want to find the right combination of these two goods, X and Y, that bring us the greatest amount of utility all within a certain budget constraint. Now, if that sounds a little bit familiar to you, it should. You'll actually, as we go through this, you'll note that this is the way we solve this is exactly the same as a nonlinear programming model that you did in QDA. So we'll walk through this problem, and we're actually going to set this up just like you set up the models in QDA, and we're going to solve for the maximizing quantities of X and Y that maximize our utility. So let's start taking some of this information, and we're going to plot it down here in the color coding that Professor Sylvia taught you. So we have good X and Y. And let's start here. So let's just interpret what this is asking us. So this is asking us to maximize utility, and utility as a function of X and Y is equal to X to the 1/2 power times Y to the 1/2 power. This is just an estimated function, just like when I give you demand or supply functions. This is a function of a person's utility, their indifference curve between X and Y. And we want to maximize utility, and we choose the maximizing quantity of X and Y such that we're subject to price of X times X plus the price of Y times Y is less than or equal to our budget. So in this case, our budget's going to be 100, and so we want it to be less than or equal to. Now we also have some yellow information here. So we have the price of good X is 1 and the price of good Y is 2. So we're going to put those in here. The price of good X is 1. The price of Y is 2. These are going to be yellow. If you'll remember, yellow is our information cells. And then we also want quantity. So this is price. We also want quantity. What's the quantity of X and Y that will maximize our utility? These right here are going to be our orange cells. This is what we want solver to change in order to maximize it. Okay, and then we also know that what do we want to maximize? We need a green cell. So this is the thing that we want to maximize. This is our utility. So here in the green cell, we're going to put in this utility function here. And it's a function of X and Y. So we would say equals X raised to 0.5 to the 1/2 times, and we're going to actually put this in parentheses here, times Y, again, the quantity of Y, raised to 0.5. And again, we'll get parentheses around here. Okay, so that's going to calculate the utility that we get once solver starts changing these, and it'll help us to maximize the utility. So we'll label this utility. Okay. Now, the last thing that we're missing here to start solving this is we also need our budget constraint. Okay, so this is going to be our French flag. So subject to, this is the constraint here, the price of X times X and the price of Y times Y. So here we can actually just do a sum product of the price and the quantity. And we want this to be less than or equal to our budget constraint of 100. So we're going to color code these here. So this is our French flag. So we're going to do blue on this side and red on this side. Okay, so now we have everything we need to start setting up solver. So we'll go here to data, solver. And the first thing that it asks us is to set the objective cell. This is our green cell. This is the thing that we want to maximize. So we're going to go ahead and select our green cell here. We also want to select maximization, right? We want it to maximize by changing variable cells. So our variable cells are orange. So we're going to select these two here. subject to the constraints. So now we add our French flag. So this is less than or equal to this, the red sign. Okay. And we want to have this checked, make unconstrained variables non-negative, meaning that we have to have positive integers for those orange cells, and we also want it to use the nonlinear model. We'll go ahead and click solve. Now, one thing we sometimes run into with Solver, you may remember this, is that sometimes Solver has a hard time. You'll notice that right here, it just put zeros in here. Sometimes Solver needs a starting place. Once you put in a starting place, it knows how to solve it, but sometimes if it's just blank, it has a hard time. So if you're getting this message, just change these to a 1 and then try it again. Just solve the model again. It gives Solver a place to start to check for all of these maximizing points, and then it can solve it for you. Okay, so now we have our utility maximizing combination of x and y. So this is saying that 50x and 25y will maximize our utility. So the maximum utility we can get is 35.35. And you'll notice that we are right at our budget constraint of 100. Hurrah! Okay, so we've solved the profit or the utility maximizing quantity of x and y. Now we're not quite done. What we want to do next is we want to actually graph the indifference curve and the budget line to demonstrate that we are right at that utility maximizing point. We're going to walk through how to do this in Excel so that you can actually graph this out and see exactly the theoretical concepts that we've talked about in class, how those apply to this problem. Okay, so the first thing we're going to graph out is our budget constraint. And so what we're going to do is we're going to plot out, so again we have x and y, and we're just going to plot out what our constraints would be if we used all of our budget. We want the two endpoints, and then it'll draw a line between. So if we spent all of our budget on x, so we have 100, if we spent all of our budget on x, how much of x and how much of y would we have? Well, since each of x costs 1, so we'd be able to get 100x and 0y. And if we spent all of our amounts on y, we would have 0x, and because they cost 2, so then it would be 50y. Okay, so these are the two endpoints of our budget constraint, if we spent all of our money on x or all of our money on y. Now, all the combinations between there represent some combination of x and y, but these two endpoints are going to give us the budget constraint for this graph. Okay, the next thing that we need to graph is going to be the indifference curve. Okay, and so what we're going to do is, again, in order to graph the indifference curve, we want all of the combinations of the amounts for x and y that give us this utility right here. Since we know that this is the most utility, the maximum utility we can get in this problem, we want to find all of the combinations of x and y that would give us this. And if we graph all of that, that's going to become one big indifference curve. So there's a couple steps to this. So the first thing that we want to do is we want to resolve this utility maximization function for y. So right now it's solved for u. We want to solve this for y. Okay, so we're going to flip over here and do just some algebra here to get this to work. Okay, so utility in this case is equal to x to the 1/2, y to the 1/2. And again, we're going to want to solve for y here. Okay, so the first thing that we're going to do is divide all of this by x to the 1/2. Divide both sides. Okay, so we have u over x to the 1/2 is equal to y to the 1/2. To get rid of this 1/2, we're going to go ahead and square the whole of both sides. And so now these cancel out. And so what we're left with is y is equal to utility over x to the 1/2, all of this squared. Now, why this is important here is what this is going to allow us to do is put in a whole bunch of different values for x. And since we're keeping a constant, which is u, that maximum utility, it will tell us all of the combinations of x and y that bring about that amount of utility. So coming back to Excel now, what we're going to do is we're going to start by just putting in a bunch of values for x and then putting in the formula to solve for y. So we're going to start with, since the maximizing point here is around 50, we'll just start, again, this is x and this is y. We're going to start with 10, 11, 12, and we're going to go all the way down to, we'll say about 90. Okay, so I want all the combinations of x and y that give me this utility. So let's go back to what we just solved with y. So y is equal to the utility. Okay, so this is the utility which we've already solved for. And we're going to lock that in because that's always going to be the same. Divided by this x raised to the 0.5. And all of this squared. Now what we can do is drag that formula down since we locked in this cell. This tells us all of the combinations of x and y that if we plugged all of these x's and y's into this formula up here, it would always come out to 35.35. So all of these combinations all equal the same amount of utility. That's why we're indifferent to all of these combinations. But at the point of 50 and 25, which is our utility maximizing point here, we can actually afford that. All of the rest of these fall outside of our budget constraint, but this one actually meets it. So now that we have our budget constraint and our indifference curve, let's go ahead and start to graph all of this. Okay, so we're going to start by just inserting a blank graph here. We're going to use, again, the scatter plot with lines. And we're going to bring this over here and let's start to select the data. So the first thing we want to select here is we're going to add a new series. So again, a series is just adding a new line on the graph. And we're going to call this one budget constraint. Okay. And for this, we're going to choose the x values here and the y values here. Okay, there we go. We have our budget constraint first. Okay, so the next thing we want to do is we're going to add another series here. So we'll go back to select data. We're going to add another series and we're going to call this one indifference curve. And the x values are going to be these ones that we set out here, and the y values right next to it. And when we click OK, we now have an indifference curve. Awesome. And this looks exactly like we expected it to, right? It has kind of this concave shape. And we can see that there's some point right in here in which these two things, the budget line and our utility, our indifference curve, are tangential to each other. Okay, we already know what that point is. That point right here is 50 and 25. So let's go ahead and just plot that point here so that we can see the utility maximizing point on top of this. So we'll just add one more constraint. We'll call this maximizing point. And for the x value, we'll select the x, and for the y value, the y. Hit OK. Now you can see this little gray dot came up here. I'm just going to change this to yellow here so it stands out a little bit more. Okay, I'm not sure why that didn't come up, but you can see, oh, I just made it yellow around the outside. But you can see here, this is the point where our indifference curve and our budget constraint are tangent to each other. It bumps right up against it. So we can confirm here that this is the point at which we achieve the highest amount of utility that's also within this budget constraint. So this is kind of how we set up one of these maximization problems. We'll practice this more in class, but give this a try and come ready with any questions that you have.